Today we're going to talk about synthetic division, a nice alternative to that long polynomial division that a lot of us struggle with all the little places we can make mistakes with. So I think you'll find that synthetic division eliminates some of those mistakes. So we're going to look at a few problems. And first of all, we want to identify that we're dividing by a binomial like this, like an x plus 5. So to start with, we want to find out what is this 0. What's going to make this equal to 0? And it's the opposite of a plus 5, so it's negative 5. Now I always start by thinking about I need to put that number in the box. So I'm going to create a little box here and put negative 5 right here. I now want to take my coefficients from this expression. So the coefficient here of 4, 23, and 16. Now what's nice about this is we start eliminating exponents, we start eliminating variables, and we get to use just numbers. Getting back to plain old math. I'm going to draw a little line under it. And remember, we're going to add numbers going down, multiply them going up and diagonal. So we start with 4 plus nothing is 4. So we put a 4 there. I now have to multiply this 4 by this number in the box of negative 5. And it goes up here as a negative 20. Just multiplying those out. Again, I'm going to add down. 23 and a negative 20 is positive 3. I now have to multiply this 3 by my number in the box. And I get negative 15. Add that down, and I get negative 31. Now, one of the main purposes we'll use synthetic division is evaluating to see if this is a factor of this polynomial. If this is 0, then this is a factor of the polynomial, and we can start working with this and reducing this number down. If not, we have a remainder. So if we divide by x plus 5, we now have to put these numbers back up into our equation as coefficients. Because we divided by an x, all of these terms get reduced by an exponent of x. So this x squared becomes a 4x. Plus 3, again we're reducing this from 1x to the first to just 0. And this gets eliminated completely and is our remainder of negative 31. So this ends up being 4x plus 3 remainder, negative 31, and we know that this is not a factor. Let's look at number 2 now. Again, we want to start by putting a number in the box. Think about this. We have x minus 2 we're dividing by. What value of x will make that equal to 0? And it's the opposite of a negative 2, which is positive 2. That's the number that goes in the box here. I copy down these coefficients. I copy down this coefficient is negative 2. This one is 3. Go down to my x's is 5. And a negative 6. Draw my line. Add down. Negative 2 and nothing is negative 2. Multiply these numbers. We get negative 4. Add down. Negative 1. 2 times negative 1 is again negative 2. Add down, I got a 3. 2 times 3 is 6. And negative 6 plus 6 is 0. Bing, 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 bing. Remainder of 0. This, x minus 2, is a factor of this polynomial. That's going to be important here in another lesson or two. Now how we rewrite our final solution, again, we started with x to the thirds and we're dividing by an x. So this x to the third has to be reduced by 1. So this coefficient of negative 2 becomes negative 2x squared. So we're 1 less here. Minus 1x plus 3. You'll notice that these exponents go down in decreasing order. X to the second, x to the first, and then no x's. And a nice 0 remainder. Now we're going to look at a little bit longer, something a little bit longer. this up a little bit. We have this. 3x to the fourth plus 6x to the third minus 5x squared plus 15x plus 9. It's a mouthful. All divided by x plus 3. Things stay the same. What number do we put in the box? What's going to make this equal to 0? Because this is plus 3, I'm going to put in negative 3 here. Coefficients. 3, 6, negative 5, 15, and 9. Bring the 3 down. Negative 3 times 3 is negative 9. 6 and negative 9, negative 3. Negative 3 times negative 3 is 9. That becomes a 4. When we multiply, we get negative 12. Add down, multiply, and again, our remainder is 0. So again, x plus 3 would be a factor of this bigger polynomial. What's left here, again, because this was x to the fourth, this becomes x to the third minus 3x to the second plus 4x plus 3. And that would be our final answer. Whoa. So again, remember, we're adding down, multiplying, going diagonal. And I have one more problem for you. I want you to think about what is different about this problem than the other ones. We have x to the third plus 7x squared minus 48, all divided by x plus 4. Now hopefully you're seeing that I see that it's x to the third, x to the second, but where's my x's? I'm missing it. So we have to create a placeholder for that. We can't just ignore it. So first of all, I'm going to start with my 0 here of negative 4. That goes in the box. Coefficient of x to the third, x squared, x's, and negative 48 for my constant. Again, there's my placeholder. Just like if we're writing numbers with zeros, like 1024, we have to put that 0 in to identify that. Add down. 1 times negative 4 is negative 4. Add down. Negative 4 times 3 is negative 12. Add down. Negative 4 times negative 12 is 48. Add down. And we do get a 0 remainder again. Worked out nice. So because we start with x to the thirds, these are x squares. This is just an x. And there's our constant. And there you go with synthetic division. It works really, really well when we just have this binomial with an x to plus or minus another number. Hopefully this helps, and I'll see you next time.